What's going on? What's going on? Back at it. Python fundamentals. Let's keep going. So, why loops? Before we get to writing our own loops, let's explore what programming would be like if we couldn't use loops. Let's say we have a list of ingredients and we want to print every element in the list. Ingredients equals milk, sugar, vanilla extract, dough, chocolate. If we only use print, our program might look like this. A bunch of print statements. The output would be milk, sugar, vanilla extract, dough, chocolate. That's still manageable. We're writing 5 print statements or copying and pasting a few times. Now imagine if we come back to this program and our list had 10 or 24,601 or 100 million elements. It would take an extremely long time, and by the end, we could still end up with inconsistencies and mistakes. Don't dwell too long on this tedious scenario. We'll learn how loops can help us out in the next exercise. For now, let's gain an appreciation for loops. Use 10 print statements. Print out. This can be so much easier with loops. Wow, they really want to make me suffer. So print. Goodness. Okay. This can be so much easier with loops. Oh, I guess here's what I'll do. Oh, damn. Why is it prints them on a new line automatically? Did you add a print statement that prints out? Oh my goodness, this really can be so much easier with loops. I don't even want to do this. If you already have an idea of how to use loops or have searched up how to do it, we're still expecting 10 individual print statements. If for some reason, make sure all the prints it. Oh. Okay. 3, 4, 5, 6, 7, 8, 9, 10. Cool. So for loops, introduction. Now that we can appreciate what loops do for us, let's start with your first type of loop, a for loop, a type of definite iteration. In a for loop, we will know in advance how many times the loop will need to iterate because we will be working on a collection with a predefined length. In our examples, we will be using Python lists as our collection of elements. With for loops, on each iteration, we will be able to perform an action on each element of the collection. Before we work with any collection, let's examine the general structure of a for loop. For temporary variable in collection action. Let's break down each of these components. A for keyword indicates the start of a for loop, a temporary variable that is used to represent the value of the element in the collection the loop is currently on. An in keyword separates the temporary variable from the collection used for iteration. A collection to loop over. In our examples, we will be using a list, an action to do anything on each iteration of the loop. Let's link these concepts back to our ingredients example. For this for loop, prints each ingredient in ingredients. So we have ingredients, milk, sugar, vanilla extract, dough, chocolate. For ingredient in ingredients, print ingredient. In this example, ingredient is the temporary variable. Ingredients, so temp variable, ingredients is our collection, and print ingredient was the action performed on every iteration using the temporary variable of ingredient. This code outputs each of those list items. Some things to note about for loops, temporary variables. A temporary variable's name is arbitrary and does not need to be defined beforehand. Both of the following code snippets do the exact same thing as our above example. For I in ingredients, print I. For item in ingredients, print item. Programming best practices suggest we make our temporary variables as descriptive as possible. Since each iteration step of our loop is accessing an ingredient, it makes more sense to call our temporary variable ingredient rather than I or item. Indentation. Notice that in all of these examples, the print statement is indented. Everything at the same level of indentation after the for loop declaration is included in the loop body and is run on every iteration of the loop. So here we see any code at this level of indentation will run on each iteration of the loop If we ever forget to indent, we'll get an indentation error or unexpected behavior. Elegant loops. Python loves to help us write elegant code, so it allows us to write simple for loops in one line. In order to see the below example as one line, you may need to expand your narrative window, but we're good. Here is the previous example in a single line. For ingredient and ingredients, print ingredient. Note, one-line for loops are useful for simple programs. It is not recommended you write one-line loops for any loop that has to perform multiple complex actions on each iteration. Doing so will hurt the readability of your code and may ultimately lead to bug your code. Let's practice writing our own for loop. So run this code. We should get an indentation error because the print game line is not indented. Indent, 2 spaces or tab, line 6, so that we don't get an indentation error when you run the code. Write a for loop that prints each sport in the list sport games. So for game in sport games, print game. Cool. For loops using range. Often we won't be iterating through a specific list or any collection, but rather we only want to perform a certain action multiple times. For example, if we wanted to print out a learning loops message 6 times using a for loop, we would follow this structure. For temporary variable in list of length 6, print learning loops. Notice that we need to iterate through a list with a length of 6, but we don't necessarily care what is inside of that list. To create arbitrary collections of any length, we can pair our for loops with the trusty Python built-in function range. An example of how the range function works: this code generates a collection of 6 integer elements from 0 to 5. So here we see 6 steps equals range 6. 6 steps is now a collection with 6 elements, 0, 1, 2, 3, 4, 5. We can then use the range directly in our for loops as the collection to perform a 6-step iteration. So for temp in range 6, print learning loops would output learning loop 6 times. Something to note is we are not using temp anywhere inside of the loop body. If we are curious about which loop iteration step we are on, we can use temp to track it. Since our range starts at 0, we will add +1 to our temp to represent how many iterations, steps, our loop takes more accurately. So for temp in range 6, print loop is on iteration number plus string temp +1 would output that. Let's try out using a range in a for loop. So use the range function in a for loop to print out the provided promise variable 5 times. So for I in length 5, or sorry, range. Was I even paying attention? For I in range 5, print promise. Nice. While loops. Introduction. In Python, for loops are not the only type of loops we can use. Another type of loop is called a while loop and is a form of indefinite iteration. A while loop performs a set of instructions as long as a given condition is true. The structure follows this pattern: while, conditional statement, action. Let us examine this example where we print the integer 0 to 3, so count equals 0, while count is less than or equal to 3. Loop body, print count, count plus equals 1. Let's break down the loop. Count is initially defined with the value of 0. The conditional statement in the while loop is count less than or equal to 3, which is true at the initial iteration of the loop, so the loop body executes. Inside the loop body, count is printed and then incremented by 1. When the first iteration of the loop is finished, Python returns to the top of the loop and checks the condition again. After the first iteration, count will be equal to 1, so the conditional still evaluates to true, and so the loop continues. This continues until the count variable becomes 4. At that point, when the conditional is tested, it will no longer be true, and the loop will stop. The output would be 0, 1, 2, 3. Note the following about while loops before we write our own: indentation. Notice that in our example, the code under the loop declaration is indented. Similar to a for loop, everything at the same level of indentation after the while loop declaration is run on every iteration of the loop while the condition is true. If we ever forget to indent, we will get an indentation error or an unexpected behavior. Elegant loops. Similar to for loops, Python allows us to write elegant one-line while loops. Here is our previous example in a single line: count equals 0, while count is less than or equal to 3, print count, count plus equals 1. Note, here we separate each statement with a semicolon to denote a separate line of code. Let's practice writing a while loop. Examine the while loop from the narrative in your code editor. So here we see this while loop walkthrough. From that, count 3, loop body, print if the condition is still true, print loop iteration. iteration minus count less than or equal to 3 is still true. Print count is currently plus string count, increment the count, and then print these lines, print while loop ended when it's all said and done. So run the code to see what happens. On each iteration of the loop, we get this. When you are finished, comment out the example to make space for the rest of the checkpoints. Comment out the example, okay. To quickly comment out the code, use your cursor to mouse. Oh, let's practice this. Cursor and press command / on a Mac. Cool. If you notice the run button spinning continuously or a lost connection to Codecademy message in an exercise, you may have an infinite loop. If the stop condition for our loop is never met, we will create an infinite loop which stops our program from running anything else. To exit out of an infinite loop in an exercise, refresh the page, then fix the code for your loop. Let's write a while loop that counts down from 10 to 0 inclusive. Once our loop is finished, we will commemorate our accomplishment by printing "we have liftoff." As we saw in the narrative, our key components will be a variable to keep track of the count and also help our loop eventually stop, a condition that our while loop will check on each iteration, several code statements to execute on each iteration of the loop. Let's tackle the first component. Create a variable named countdown, set the value equal to 10. So countdown equals 10. Now let's tackle the actual while loop. Define a while loop that will run while our countdown variable is greater than or equal to 0. So while countdown is greater than or equal to 0. On each iteration, we should print the value of the countdown variable. So print countdown. And we should decrease the value of the countdown variable by 1. Countdown minus equals 1. Or here, let's get fancy. Countdown minus minus. We should decrease the value. Make sure to only print the value of the countdown. Can we do minus minus in Python? I get my languages confused. Make sure to only print the value of the countdown. Cool. Yeah, we can't do that. My fault. Thought I was smarter than I actually was. Now that we have built our loop, let's commemorate our success by printing "we have liftoff" after the while loop. So copy that and then unindent it and do a print this string. Cool. While loops lists. A while loop isn't only good for counting. Similar to how we saw for loops working with lists, we can also use while loops to iterate through a list as well. Let's return to our ingredient list. Ingredients equals milk, sugar, vanilla extract, dough, chocolate. We know that while loops require some form of a variable to track the condition of the loop to start and stop. Take some time to think about what we would use to track whether we need to stop the loop if we want to iterate through ingredients and print every element. So I guess think about what we would use to track whether we need to stop the loop if we want to iterate through ingredients and print every element. So I guess while Python topics something, print Python topics. So I guess, oh, sorry. Print. I equals 0. So while Python topics. I guess. So while I is less than 1, 2, 3, 4, 5. So while I is less than or equal to 4. Print Python topics I. So I equals 0. While I is less than or equal to 4, print Python topics I plus equals 1. So on the first one, we're going to do Python topics 0. Next run, and then I will be 1. Next run, we're going to print control flow. Then I will be 2. Then we'll print loops. I will be 3. Then we'll print modules. I'll be 4. Then we'll print classes. I'll be 5, and we'll end it. So click here to find out. We know that a list either uses length. Oh, yeah, okay. So pretty much the same idea. It's just that they use length to automatically find the length of Python topics. So we know that a list has a predetermined length. If we use the length of the list as the basis for how long our while loop needs to run, we can iterate the exact length of the list. We can use the built-in Python length function to accomplish this. Length would be equal to 5, so length equals length of ingredients. We can then use this length in addition to another variable to construct the while loop. So length equals length of ingredients, index equals 0, while index is less than length, print ingredients index, index plus equals 1. Let's break this down. Length will be 5 in this case. So explanation, as mentioned, we need a way to know how many times we need our loop to iterate based on the size of the collection. This comes in the form of our length variable, which stores the value of the length of the list. Index starts at 0, index equals 0. We still need an additional variable that will be used to compare against our length, while index is less than length. In our while loop conditional, we will compare the index variable to the length of our list stored inside of the length variable. On the first iteration, we will be comparing the equivalent of 0 is less than 5, which will evaluate to true, and start the execution of our loop body. And then the first iteration will print ingredients 0. Inside of our loop body, we can use the index variable to access our ingredients list and print the value at the current iteration. Since our index starts at 0, our first iteration will print the value of the element at the 0th index of our ingredients list. Then the next iteration will print the value of the element at the first index, and so on. So here we see this increment. On each iteration of our while loop, we need to also increment the value of the index to make sure our loop can stop once the index value is no longer smaller than the length value. This increment also helps us access the next value of the ingredients list on the next iteration. Our final output would be milk, sugar, vanilla extract, dough, chocolate. Let's use a while loop to iterate through some lists. We are going to write a while loop to iterate over the provided list Python topics. First, we will need a variable to represent the length of the list. This will help us know how many times our while loop needs to iterate, create a variable length, and set its value to be the length of the list Python topics. So length equals len Python topics. Next, we will require a variable to compare to our length variable. Cool, already done. Oh yeah, we don't want to call it index, so index. Let's now build our loop. So if we just change this to index is less than length. What'd I do wrong? What'd I do? Script and module name I is not defined. Oh, index name I is not. Where'd I put I? Does not look like your output matches what we expected. Always wrong. What'd I do? Okay, let's find out. Let's read actually. Let's now build our loop. We want a loop to iterate over the list of Python topics, and on each iteration, print I am learning about. Oh, I see. Print I am learning about plus this element from Python topics. For this loop, we will need the following components: a condition for our while loop, a statement in the loop body to print from our condition, a statement in the loop body to increment our index forward. The end result should output I'm learning about variables, I'm learning about control flow. So we're already printing out the right things, and now we added I am learning about. If you notice the run button spinning continuously, which we won't because we're dope, infinite loops. We've iterated through our lists that have a discrete beginning and end. However, let's consider this example. My favorite numbers equals 4, 8, 15, 16, 42. For a number in my favorite numbers, my favorite numbers dot append 1. Take some time to ponder what happens with this code. So we end up getting 4, 8, 15, 16, 42. That's 5 numbers. And so this will just be these numbers plus a bunch of 1s at the end. Every time we enter the loop, we add a 1 to the end of the list that we are iterating through. As a result, we never make it to the end of the list. It keeps growing forever. Oh yeah, true. That's funny. A loop that never terminates is called an infinite loop. These are very dangerous for our code because they will make our program run forever and thus consume all of your computer's resources. A program that hits an infinite loop often becomes completely unusable. The best course of action is to avoid writing an infinite loop. Note, if you accidentally stumble into an infinite loop while developing on your own machine, you can end the loop by using Ctrl+C to terminate the program. If you are writing code in our online editor, you'll need to refresh the page to get out of an infinite loop. Let's fix an infinite loop to see it in action. Suppose we have two lists of students, students period A and students period B. We want to combine all students into period B. In your code editor, we have provided you a loop. Go ahead and uncomment line 5, and before you run the code, ponder why this code would cause an infinite loop. So if we uncomment this, so for student in students period A, students period A dot append student, print student. So obviously we're just going to keep adding to the list and it's never going to end. When you already run this code, what do you notice happens? Over the run button, notice the loading circle is continuing without anything happening. This is an infinite loop. To end this program, we must refresh the page. Note the reason this loop is infinite is that we are adding each student in periods student A to students period A, which would create a never-ending list of all the student names. Open this after you refresh the page, delete the line causing the infinite loop, and fix it to accomplish the original goal of combining all students from students period A into students period B. So for student in students period A, students period B dot append student, and then print student. This is still an infinite loop. Why? So for each student in students period A, we're appending this. So Dora dot dot dot. Let's think critically. For student in students period A, so there are 4 students in that variable. There are 4 students in Dora, Manura, Alexa, Obi, in students period B. So we're appending student period B with the student, and then we print the student, and eventually we should get to the end of students period A and we should be done. A little bit confused here, but this is why I'm learning these fundamentals, right? Okay, I don't know why. Whatever. Fine, we got it. Faked me, psyched me out, made me think I was doing something wrong. Loop control break. Loops in Python are very versatile. Python provides a set of control statements that we can use to get even more control out of our loops. Let's take a look at a common scenario that we may encounter to see a use case for loop control statements. Take the following list, items on sale, as our example. Items on sale: blue shirt, striped socks, knit dress, red headband, dinosaur onesie. It's often the case that we want to search a list to check if a specific value exists. What does our loop look like if we want to search for the value of knit dress and print out found it if it did exist? It would look something like this. For item in items on sale, if item is equal to knit dress, print found it. This code goes through each item in items on sale and checks for a match. This is all fine and dandy, but what's the downside? Once knit dress is found in the list, items on sale, we don't need to go through the rest of the items on sale list. Unfortunately, our loop will keep running until we reach the end of the list. Since it's only 5 elements long, iterating through the entire list is not a big deal in this case, but what if items on sale had 1,000 items? What if it had 100,000 items? This would be a huge waste of time for our program. Thankfully, you can stop iteration from inside the loop by using break loop control statement. When the program hits a break statement, it immediately terminates a loop. For example, items on sale: blue shirt, striped socks, knit dress, red headband, dinosaur onesie. Print checking the sale list for item in items on sale, print item. If item is equal to knit dress, break, print end of search. This would produce the output: checking the sale list, blue shirt, striped socks, knit dress, end of search. When the loop entered the if statement and saw the break, it immediately ended the loop. We didn't need to check the elements of red headband or dinosaur onesie at all. Now let's break some loops. You have a list of dog breeds you can adopt. Dog breeds available for adoption. Using a for loop, iterate through the dog breeds available for adoption list and print out each dog breed. Use the temporary variable name of dog breed in your loop declaration. So for dog breed in, I don't want to type that. We're just printing each one, print out each dog breed, okay? Inside your for loop, after you print each dog breed, check if the current element inside dog breed is equal to dog breed I want. If so, print they have the dog I want. Okay, so print the dog breed. If dog breed is equal to dog breed I want, print this and break them. Add a break statement when your loop has found dog breed I want, so that the rest of the list does not need to be checked once we have found our bread or our breed. Cool. Loop control, continue. While the break control statement will come in handy, there are other situations where we don't want to end the loop entirely. What if we only want to skip the current iteration of the loop? Let's take this list of integers as our example. Big number list equals 1, 2, -1, 4, -5, 5, 2, -9. What if we want to print out all the numbers in a list, but only if they are positive integers? We can use another common loop control statement called continue. For I in big number list, if I is less than or equal to 0, continue, print I. This would produce the output 1, 2, 4, 5, 2. Notice a few things. Similar to when we're using the break control statement, our continue control statement is usually paired with some form of a conditional if, elif, else. When our loop first encountered an element, -1, that met the conditions of the if statement, it checked the code inside the block and saw the continue. When the loop then hold on, I'm not paying attention. Let's start over. While the break control statement will come in handy, there are other situations where we don't want to end the loop entirely. What if we only want to skip the current iteration of the loop? Let's take this list of integers as our example. What if we want to print out all the numbers in a list, but only if they are positive integers? We can use another common loop control statement called continue. So for I in big number list, if I is less than or equal to 0, continue, print I. This would produce the output 1, 2, 4, 5, 2. Notice a few things. Similar to when we were using the break control statement, our continue control statement is usually paired with some form of a conditional, if, else. When our loop first encountered an element, -1, that met the conditions of the if statement, it checked the code inside the block and saw the continue. When the loop then encounters a continue statement, it immediately skips the current iteration and moves on to the next element in the list, 4. The output of this list only printed positive integers in the list, because every time our loop entered the if statement and saw the continue statement, it simply moved to the next iteration of the list and thus never reached the print statement. Let's continue learning about control statements with some exercises. Your computer is the doorman at a bar in a country where the drinking age is 21. Loop through the ages list. If an entry is less than 21, skip it and move to the next entry, otherwise print the age. So, for age in ages, if age is less than 21, continue, otherwise print the age. Print age. Cool. Nested loops. Loops can be nested in Python as they can with other programming languages. We will find certain situations that require nested loops. Suppose we are in charge of a science class that is split into 3 project teams. Project teams are Ava, Samantha, James, Lucille, Zed, and Edgar, Gabriel. Using a for or while loop can be useful here to get each team. For team and project teams, print team would output these 3 lists. But what if we wanted to print each individual student? In this case, we would actually need to nest our loops to be able to loop through each sublist. Here's what it would look like. Loop through each sublist, so for team in project teams, and then loop elements in each sublist. For student in team, print student. This would output each student. Let's practice writing a nested loop. We have provided the list of sales data that shows the number of scoops sold for different flavors of ice cream at 3 different locations: Scoop Academy, Gilbert's Creamery, and Manny's Scoop Shop. We want to sum up the total number of scoops sold across all 3 locations. Start by defining a variable scoops sold and set it equal to 0. So scoops sold equals 0. Loop through the sales data list using the following guidelines. For our temporary variable of the for loop, call it location. So for location in, print out each location in the list. So for location in sales data, print location. Do we have to name them? I don't think so. Within our sales data loop, nest a secondary loop to go through each location sublist element and add the element value to scoop sold. By the end, you should have the sum of every number in the sales data nested list. Okay, so for location in sales data, for sale in location, scoops sold plus equals sale. Do we have to print it? Then our sales data loop nests a secondary loop to go through each location sublist and add the element value to scoop sold. By the end, you should have the sum of every number in the sales data nested list. I know I see it coming, so I'll ignore it for now. And then now we're going to print out the value of scoops sold outside of the nested loop. So print scoops sold. List comprehensions. Introduction. So far we have seen many of the ideas about using loops in our code. Python prides itself on allowing programmers to write clean and elegant code. We have already seen this with Python giving us the ability to write while and for loops in a single line. In this exercise, we are going to examine another way we can write elegant loops in our programs using list comprehensions. To start, let's say we had a list of integers and wanted to create a list where each element is doubled. We could accomplish this using a for loop and a new list called doubled. So numbers 2, -1, 79, 33, -45. Doubled is this empty list. And for number in numbers, doubled.append number times 2, print doubled, would output each of the numbers from the original list multiplied by 2. Let's see how we can use the power of list comprehensions to solve these types of problems in one line. Here's our same problem, but now written as a list comprehension. So numbers equals 2, -1, 79, 33, -45. Doubled equals num times 2 for num in numbers, print doubled. Let's break down our example in a more general way. New list equals square brackets expression for element in collection. In our doubled example, our list comprehension takes an element in the list numbers. So we take an element in the list numbers. We assign that element to a variable called num. So num times 2 for num. And we apply the expression. So we're just 1 and 2 is this. We're taking an element in the list numbers and assigning that element to a variable num. Then we apply this expression on the element stored in num, and we add the result to a new list called doubled. Repeats steps 1 through 3 for every other element in the numbers list, our collection. Our result would be the same. We have been provided a list of grades in a physics class. Using a list comprehension, create a new list called scaled grades that scales the class grades based on the highest score. Since the highest score is 90, we simply want to add 10 points to all the grades in the list. So this is scaled grades equals grade plus 10 for grade in grades. And then we want to print scaled grades. Cool. List comprehensions, conditionals. List comprehensions are very flexible. We even can expand our examples to incorporate conditional logic. Suppose we wanted to double only our negative numbers from our previous numbers list. We will start by using a for loop and a list only negative doubled. So here we have numbers is those numbers, only negative doubled. For num in numbers, if num is less than 0, only negative doubled, append num times 2, print only negative doubled would output those. Now, here's what our code would look like using a list comprehension. So we have the same numbers list. We have negative doubled equals num times 2 for num in numbers. If num is less than 0, print negative doubled would output the same result. In our negative doubled example, our list comprehension takes an element in the list numbers, assigns that element to a variable called num, checks if the condition num less than 0 is met by the element stored in num. If so, it goes to step 4. Otherwise, it skips it and goes to the next element in the list, applies the expression num times 2 on the element stored in num, and adds the result to a new list called negative doubled. Repeats steps 1 through 3 and sometimes 4 for each remaining element in the numbers list. We can also use if-else conditions directly in our comprehensions. For example, let's say we wanted to double every negative number but triple all positive numbers. Here's what our code might look like. So we have numbers is this list, doubled equals num times 2 if num is less than 0, else num times 3 for num in numbers, print doubled would output that list. Note, this is a bit different than our previous comprehension, since the conditional if num is less than 0, else num times 3 comes after the expression. Hold on, pay more attention. So here we have doubled equals num times 2 if num is less than 0, else num times 3 for num in numbers. Note, this is a bit different than our previous comprehension, since the conditional if num is less than 0 includes an else clause The conditional must go before 4. Attempting to write the expressions in any other order will result in a syntax error. Here are a few list comprehensions in a single block. Take a moment to compare how the syntax must change depending on whether or not an else clause is included. So the same numbers list, no if. So num times 2 for num in numbers, if only. So num times 2 for num in numbers if num is less than 0, and then if else. So num times 2 if num is less than 0, else num times 3 for num in numbers. Now, let's write our own list comprehensions with conditionals. We have to find a list of heights of visitors to a theme park right here. In order to ride the topsy-turvy Tumbletron roller coaster, you need to be above 161 centimeters. Using a list comprehension, create a new list called Can Ride Coaster that has every element from heights that is greater than 161. If height for height in heights. Okay. So okay, wait. Can ride coaster equals height for height in heights if height is greater than 161. You need to be above 161. Cool. So yeah. Print can ride coaster. Review. Good job. In this lesson, you learned how to write a for loop, how to use range in a loop, how to write a while loop, what infinite loops are and how to avoid them, how to control loops using break and continue, how to write elegant loops as list comprehensions. Let's get some practice with these concepts. Create a list called single digits that consists of the numbers 0 through 9 inclusive. Let's do this in a fancy way. So single digits equals an empty list. For number in range, that'll be 10. Single digits dot append number. Let's get it. Create a loop. Create a for loop that goes through single digits and prints each one. So for digit in single digits, print digit. Before the loop, create a list called squares. Assign it to be an empty list to begin with. Inside the loop that iterates through single digits, append the squared value of each element of single digits to the list squares. You can do this before or after printing the element. So squares dot append digit times squared, right? So the loop that iterates through single digits, append the squared value of each element of single digits to the list squares. You can do this before or after printing the element. That's not how you do it. You got to do it to the second power like that. After the for loop, print out squares. Print squares. Create the list cubes using a list comprehension on the single digit list. So cubes equals digit to the third power for digit in single digits. So create the list cubes, use the list comprehension on the single digits list. Each element of cubes should be an element of single digits taken to the third power. Print cubes. Good job. Dopeness. Fill in the code to loop over the list grouped topics and print every element in the list. So we have grouped topics equals algorithms, data structures, AI, linear regression, SQL. For sublist in grouped topics, for subelement in sublist, print sublist element. Check answer. Cool. Fill in the blank with the appropriate while condition in order to print the numbers 1 through 10 in order. I equals 1, blank, print I plus equals 1. So I equals 1, while what are we trying to do? Fill in the blank with the appropriate while condition in order to print the numbers 1 through 10 in order. Okay, so while I is less than or equal to 10, print I, and then I plus equals 1. What would be the output of the following code? Drink choices equals coffee, tea, water, juice, soda. For drink and drink choices, print drink would be coffee, tea, water, juice, soda. What would be the output of the following code? Numbers equals 1, 1, 2, 3. For number and numbers, if number modulo 2 is equal to 0, continue. Otherwise, print numbers. So numbers 1 modulo 2 is not equal to 0, right? Yeah. Number 2 modulo 2 is equal to 0. Number 3 is not. So we would only see 1, 1, and 3. What would be the output of the following code? Numbers equals 2, 4, 6, 8. For number in numbers, print hello. We're going to get 4 hellos. What would be the output of the following code? For I in range 3, print 5. So we get 0, 1, 2. We get print 5. So we're going to get 3 5s. Which of these list comprehensions will create a list equal to desired list? Desired list equals this, and those aren't even list comprehensions. So I for I in range 5, or I minus 1 for I in range 5. Which of these list comprehensions will create a list equal to desired list? Okay. A desired list equals this empty, but that. Okay, so range 5 doesn't make any sense. Desired list equals an empty list for I in range 5. Desired list equals I minus 1. No. I for I in range 5. So print out. No. I minus 1 for I in range 5 would be the correct answer. What would be the output of the following code? Numbers equals 1, 1, 2, 3. For number in numbers, if number modulo 2 is equal to 0, break, print number. So 1, if number, so ignore that, we never enter that. We print the number, so we print 1. So if number modulo 2, no, we print 1 again. Number modulo 2, 0, break it. So just 1, 1. What would be the output of the following code? For I in range 3, print I, 0, 1, 2. Which of these list comprehensions will create a list equal to desired list? My list equals 5, 10, negative 2, 8, 20. Desired list equals 10, 8, 20. Which of these list comprehensions will create a list equal to desired list? So new list equals I for I in my list if I is greater than 5. So that would print this, that wouldn't print that, would print this, and that would print this. I think that is the one. So I plus 5. Let's just go with that. Continue learning. Not doing the projects. So syllabus. Sorry, Carly. Functions. Let's get to it. For some reason, it loves to just take a long time to respond to clicking in the syllabus. Introduction to functions. In programming, as we start to write bigger and more complex programs, one thing we will start to notice is we will often have to repeat the same set of steps in many different places in our program. Let's imagine we were building an application to help people plan trips. When using a trip planning application, we can say a simple procedure could look like this. Establish your origin and destination, calculate the distance route, return the best route to the user. We will perform these 3 steps every time users have to travel between 2 points using our trip application. In our programs, we could rewrite the same procedures over and over for each time we want to travel, but there's a better way. Python gives us a useful concept called functions. Functions are a convenient way to group our code into reusable blocks. A function contains a sequence of steps that can be performed repeatedly throughout a program without having to repeat the process of writing the same code again. In this lesson, we are going to explore the idea of a function by slowly building out a Python program for our trip planning steps. At the end of this lesson, you'll know how to write a function and return values from it, allow functions to take custom input, experiment with how functions access our other Python code, and much more. Instructions: review the visual for the function navigation steps. Notice how the function navigation steps serves as a container for the 3 steps in the procedure and can be reused across multiple users as they plan their trips to different locations. Click next when you are ready to learn more about functions. So, let's see here. We have this: establish your starting and endpoints, calculate the distance route, return the best route. Okay, so this person is establishing their starting and endpoints, they're calculating the distance, and then they are returning the best route to get to Budapest. Sounds cool. Why functions? Let's come back to the trip planning application we just discussed in the previous exercise. The steps we talked about for our program were: 1. Establish an origin and destination. 2. Calculate the distance/route. 3. Return the best route. If we were to convert our steps into Python code, a very simple version that plans a trip between 2 popular New York tourist destinations might look like this. Print, setting the Empire State Building as the starting point and Times Square as our destination. Print, calculating the total distance between our points. Print, the best route is by train and will take approximately 10 minutes. Anytime we want to go between these 2 points, we would need to run these 3 print statements. For now, we can assume the best route and time will stay the same. If our program now had 100 new people trying to find the best directions between the Empire State Building and Times Square, we would need to run each of our 3 print statements 100 times. Now, if you're thinking about using a loop here, your intuition would be totally right. Unfortunately, we won't be always traveling between the same 2 locations, which means the loop won't be as effective when we want to customize a trip. We will address this in the upcoming sections. For now, let's gain an appreciation for functions. Don't make me do this. Run the pre-written print statements to see what they output. Cool. Write the same set of print statements 3 more times, run the code again, and see the output. Yep. What'd I do wrong? Uh-oh. I did something wrong. What did I do? I'm trying to hit Command Z. Oh, it's because I started on that line. Now we're good. Hopefully now you have some perspective about your life without functions. In the next section, we'll learn how we can refactor our code to utilize functions to reuse code. Click Run your code again, and then click Next to continue. Defining a function. A function consists of many parts, so let's first get familiar with its core, a function definition. Here's an example of a function definition. Def function name, function tasks, go here. There are some key components we want to note here. The def keyword indicates the beginning of a function, also known as a function header. The function header is followed by a name in snake case format that describes the task the function performs. It's best practice to give your functions a descriptive yet concise name. Following the function name is a pair of parentheses that can hold input values known as parameters. More on parameters later in the lesson. In this example function, we have no parameters. A colon to mark the end of the function header. Lastly, we have 1 or more valid Python statements that make up the function body, where we have our Python comment. Notice we've indented our function tasks go here comment. Like loops and conditionals, code inside a function must be indented to show that they are part of the function. Here is an example of a function that greets a user for our trip planning application. Dev trip welcome, print welcome to Tripcademy, print let's get you to your destination. Note, pasting the code into the editor and clicking run will result in an empty terminal, or an empty output terminal. The print statements within the function will not execute since our function hasn't been used. We will explore this further in the next exercise. For now, let's practice defining a function. 2 of the most common NYC attractions include the Empire State Building and Times Square. In travel.py, we will write a function that prints the directions via subway from the Empire State Building to Times Square. First, define a function, directions to Times Square. Leave the body of the function empty for now, so def that. Note, when we run the code, we will see an error, syntax error, unexpected EOF while parsing. First of all, I forgot the colon. Unexpected EOF while parsing. This will occur when we don't populate a function with any statements. We will populate it with code in the next step. EOF stands for end of file. Python is telling you that it was expecting some code in the body of the function, but it hit the end of the file first. Within the body of the function, Use 3 print statements to output the following directions. So here we go. Print that, oops, oops, doops, yo, yes sir, okay, no, print this, quotes, copy, paste, next, print, parentheses, quotes, copy, paste. Remember, if you run your code, you shouldn't see any output in the terminal at this point. Check out the hint if you want to see how to see the output. We'll be doing it in the next section as well. I'm going to go ahead and say directions equals directions 2 times square, and then print directions. Yo. Why did it print none though? Oh, we don't have to do all that. Oh, I see. Cool. So if we had just done this, then does it just print it out? Ah, cool. Calling a function. Now that we've practiced defining a function, let's learn about calling a function to execute the code within its body. The process of executing the code inside the body of a function is known as calling it. This is also known as executing a function. To call a function in Python, type out its name followed by parentheses. Let's revisit our directions to times square function. To call our function, we must type out the function's name followed by a pair of parentheses and no indentation. Calling the function will execute the print statements within the body and result in the following output. Note that you can only call a function after it has been defined in your code. Now it's your turn to call a function. Call the directions to times square function. Click run. Add an additional print statement to our directions to times square function. Have the statement print take lots of pictures. Run the code and see it change. White space and execution flow. Consider our welcome function for our trip planning application. There we go. The print statements all run together when trip welcome is called. This is because they have the same base level of indentation, 2 spaces. In Python, the amount of white space tells the computer what is part of a function and what is not part of a function. If we wanted to write another statement outside of trip welcome, we would have to unindent the new line, like so. Our trip welcome function steps will not print while we look at the weather outside, blah, blah. On our function call, the print statement was unindented. The show was not part of the function body, but rather a separate statement. We would see the following output from the program. That stuff. Welcome trip. I see. Lastly, note that the execution of a program always begins on the first line. The code is then executed one line at a time from top to bottom. This is known as execution flow and is the order a program in Python executes code. Whoa, look at the weather outside. Don't walk, take the train was printed before the print statements from the function trip welcome. Even though our function was defined before our lone print statement, we didn't call our function until after. Let's play around with indentation and the flow of execution. We're going to help our trip planner users figure out if they should travel today based on the weather. Let's let our users know we can check the weather for them. Write a print statement that will output checking the weather for you. We took a look outside and see a bright sunny day. Write a function called weathercheck that will print out a message to our users that it's a great day to travel. The function should output, looks great outside, enjoy your trip. No, don't call your function just yet. We'll do that in the next step. Oh no, it looks like some clouds came in and it started raining. Our users shouldn't go on a trip in the rain. In our weather check function, add a second print statement under the first one that prints a warning message for our travelers. It should print that. Alright, so print, call the function weather check. Unindent the final print statement, the one starting with false alarm. In your weather check function, run the program again. What's different this time? I'll print out in the middle, and now we're good. Parameters and arguments. Let's return to our trip welcome function one more time. Let's modify our function to give a welcome that is a bit more detailed. Def trip welcome print welcome to Tripcademy, print looks like you're going to Times Square today, trip welcome. This will output, welcome to Tripcademy, looks like you're going to Times Square today. Our function does a really good job of welcoming anyone who is traveling to Times Square, but does a really poor job if they're going anywhere else. In order for us to make our function a bit more dynamic, we are going to use the concept of function parameters. Function parameters allow our function to accept data as an input value. We list the parameters a function takes as input between the parentheses of a function. Here is a function that defines a single parameter. Def my function single parameter. In the context of our trip welcome function, it would look like this. Def trip welcome destination, print welcome to Tripcademy, print looks like you're going to, plus destination plus today. In the above example, we define a single parameter called destination and apply it in our function body in the second print statement. We are telling our function it should expect some data passed in for destination that it can apply to any statements in the function body. But how do we actually use this parameter? Our parameter of a destination is used by passing in an argument to the function when we call it trip welcome Times Square. This would output welcome to Tripcademy, looks like you're going to Times Square today. To summarize, here's a quick breakdown of the distinction between a parameter and an argument. The parameter is the name defined in the parenthesis of the function and can be used in the function body. Parameters are treated like variables within a function. The argument is the data that is passed in when we call the function, which is then assigned to the parameter name. Let's write a function with parameters and call the function with an argument to see it all in action. We want to create a program that allows our users to generate the directions for their upcoming trip. Create a function called generate trip instructions that defines one parameter called location. Def generate trip instructions, and it takes a parameter called location. Note, since we did not define any code in our function yet, we will receive an error in our output terminal. Don't worry, we'll be filling in the code in the next step. Generate trip instructions should print out the following. Looks like you are planning a trip to visit this location, so print. Generate trip instructions should also let our users know they can reach their location using public transit. Let's have generate trip instructions also print out the following. On a new line, you can use the public subway system to get to location. Where location will represent the location parameter. Time for some greenery. Let's see what happens when we call the function and input the argument Central Park. So generate trip instructions Central Park, backyard wonder in the heart of New York City. The day trip is over and we need to get back to the train station to head home. Change the argument to Grand Central Station and call the function again. Cool. Multiple parameters. Using a single parameter is useful, but functions let us use as many parameters as we want. That way we can pass in more than one input to our functions. We can write a function that takes in more than one parameter by using commas. So def my function parameter 1, parameter 2, parameter 3. When we call our function, we will need to provide arguments for each of the parameters we assigned in our function definition. Calling my function argument 1, argument 2. For example, take our trip application's trip welcome function that has two parameters. Def trip welcome, origin, destination. And looks like you're traveling from origin, you're heading to destination. Okay, I get it. Our travel application users want to calculate the total expenses they may have to incur on a trip. Write a function called calculate expenses. So replace this. So def calculate expenses. Function, place function with function name that will have 4 parameters exactly. So in this exact order. So it's taking in plane ticket prices. Let's see, I want to experiment a little here, so I'm gonna use some indentation. So plane ticket prices, car rental rate, hotel rate, and trip time. Each of these parameters will account for different expense that our users will incur. Like before, we will see a syntax error unexpected EOF. So we can't do that. Oh, no, we can. I just forgot to add commas. Did you define the function calculate expenses with 4 parameters: plane, ticket, price. Cool. Within the body of the function, let's start to make some calculations for our expenses. First, let's calculate the total price for a car rental. Create a new variable called car rental total. That is the product of car rental rate and trip time equals car rental rate times trip time. Next, we want to apply the same logic for our hotel rate. Create a new variable called hotel total. That is the product of hotel rate and hotel rate times trip time. What did I do? So create a new variable called hotel total. That is the product of hotel rate times trip time. We also have a coupon to give users some cash back for their hotel visit, so subtract 10 from that total in the same statement. Woohoo, coupons. Lastly, create a new variable called trip total. Oops. Trip total equals, that is the sum of car rental total, hotel total, plus plane ticket price. Note, do not delete return trip total at the end of the function. This will output your new variable when the function is called. Call your function with the following argument values for the parameters listed. So calculate expenses 200, 100, 100, 5. Be sure to call your function inside of print so you can see the output. Okay, so nice. Types of arguments. In Python, there are 3 different types of arguments we can give a function. Positional arguments, arguments that can be called by their position in the function definition. Keyword arguments, arguments that can be called by their name. Default arguments, arguments that are given default values. Positional arguments are arguments we have already been using. Their assignments depend on their positions in the function call. Let's look at a function called calculate taxi price that allows our users to see how much a taxi would cost to their destination. So def calculate taxi price, miles to travel, rate, discount, print miles to travel times rate minus discount. In this function, miles to travel is positioned as the first parameter, rate is positioned as the second parameter, and discount is the third. When we call our function, the position of the arguments will be mapped to the positions defined in the function declaration. Alternatively, we can use keyword arguments, where we explicitly refer to what each argument is assigned to in the function call. Notice in the code example below that the arguments do not follow the same order as defined in the function declaration. Rate equals 0.5, discount equals 10, miles to travel equals 100. Lastly, sometimes we want to give our function parameters default values. We can provide a default value to a parameter by using the assignment operator equals. This will happen in the function declaration rather than the function call. Here's an example where the discount argument in our calculate taxi price function will always have a default value of 10. So we have def calculate taxi price, miles to travel, rate, discount equals 10, print miles to travel times rate minus discount. When using a default argument, we can either choose to call the function without providing a value for a discount, and thus our function will use the default value assigned, or overwrite the default argument by providing our own. So we could use the default value of 10 by just doing calculate taxi price 10, 0.5, or we could overwrite the default value of 10 with 20 by passing 10, 0.5, 20. So Tripcademy, our trusty travel app, needs to allow passengers to plan a trip. We'll write a function called trip planner. That will have 3 parameters. First destination, oops, I know. Give the final destination parameter default value of Codecademy HQ. Oh, my fault. Since we did not define our function, receive an error in our output terminal. Don't worry, we'll be filling in the code in the next step. Did you define the function trip planner? I thought that I did. First destination, second destination, final destinatio. First, we want to introduce the trip to users. Use print in our function to output. Here is what your trip will look like. In our function definition, let's provide an itinerary that will describe the destinations our user will visit in order. Print a statement that follows this form. First, we will stop in, so then plus second destination plus and lastly plus final destination. An example to call to our function using positional arguments should output that. Let's test out our function call trip planner with the following values for parameters. Shift France, Germany, and Denmark. Does your print statement start with first? We will stop in plus first destination, then stop in first destination, then second destination, and lastly plus final destination. Trip planner. What did I do wrong? Oh, the indentation. Call the function trip planner again with the following values for the parameters. Denmark, France, Germany. Note the difference in your output depending on the position of your arguments. Call the function trip planner again. Paste. But this time include the keyword arguments, first definition, and then put them in this exact order. So first destination is this. Final destination will be this. Oops. And second destination will be this. Lastly, go ahead and call the function trip planner. Using only two positional arguments to see the default argument in action. So we do Brooklyn and Queens. Nice. Built-in functions versus user-defined functions. There are two distinct categories for functions in the world of Python. What we have been writing so far in our exercises are called user-defined functions, functions that are written by users like us. There is another category called built-in functions, functions that come built into Python for us to use. Remember when we were using print or string, both of these functions are built into the language for us, which means we've been using built-in functions all along. There are lots of different built-in functions that we can use in our programs. Take a look at this example of using len to get the length of a string. So destination name equals all of that. Built-in function len, length of function equals len destination name. Built-in function print length of destination would output the value of length of destination, which is 28. Here we're using a total of two built-in functions in our example, print and len. And yes, if you're wondering, this is a real railway station in India. There are even more obscure ones like help, where Python will print a link to documentation for us and provide some details. So help string would output shortened for readability, name string, a collection of string constants, module reference, following documentation is automatically blah, 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 blah. Check out all the latest built-in functions in the official Python docs. Let's practice using a few of them You will need to rely on the provided Python documentation links to find your answers. We were provided a list of prices for some gift shop items. T-shirt, blah. Create a variable called max price and call the built-in function max. So def max price. Oh, sorry, create a variable. So max price equals max. Call the built-in max with the variables of prices to get the maximum price. Print max price. So max t-shirt price, shorts price, mug price, poster price, and then we print max price. Using the same set of prices, create a new variable called min price. And use the built-in min function with the variables to get the price, to get the minimum price, and then print it. Not you. Go away. Use the built-in function round to round the price of the variable t-shirt price by 1 decimal. So round t-shirt price. Save the results to a variable called rounded price and print it. What did I do wrong? Did you assign a variable rounded price to be equal to the result of the round function with 1 decimal place of rounding? I see. There we go. And if we change this to 10, well, it's not going to do that because it doesn't even have that many decimals, but cool. Variable access. As we expand our programs with more functions, we might start to ponder, where exactly do we have access to our variables? To examine this, let's revisit a modified version of the first function we built out together. Def trip welcome destination print. Looks like you're going to the plus destination plus today. What if we wanted to access the variable destination outside of the function? Could we use it? Take a second to think about what the following program will output, then check the result below. Def trip welcome destination print. Looks like you're going to the plus destination plus today. Print destination. What do not paying attention. Okay. Pay attention. So, as we expand our programs with more functions, we might start to ponder, where exactly do we have access to our variables? To examine this, let's revisit a modified version of the first function we built out together. So def trip welcome destination print looks like you're going to the plus destination plus today. What if we wanted to access the variable destination outside of the function? Could we use it? Take a second to think about what the following program will output, then check the result below. So it's going to be an error. Name error, name destination is not defined. If we try to run this code, we will get a name error telling us that destination is not defined. The variable destination has only been defined inside the space of a function, so it does not exist outside the function. We call the part of a program where a destination can be accessed its scope. The scope of destination is only inside the trip welcome. Take a look at another example. Budget equals 1,000. Here we are using a default value for a parameter of destination. Def trip welcome destination equals California. Print looks like you're going to plus destination. Print your budget for this trip is plus string budget. Print budget trip welcome. So 1,000 looks like you're going to California. Your budget for this trip is 1,000. Here we are able to access the budget both inside the trip welcome function as well as our print statement. If a variable lives outside of any function, it can be accessed anywhere in the file. We will be exploring the concept of scope more after this lesson, but for now, let's play around. Note, working with multiple functions can be a bit overwhelming at first. Don't hesitate to use hints or even look at the solution code if you get stuck. Our users want to be able to save a list of their favorite places in our travel application. We have received a rough draft for this implementation from another coder, but there are some problems with variable scope which prevent it from working properly. Take a second to understand what the program is doing and then hit run the code to see the error. So this function will print a hard-coded count of how many locations we have. Def print count locations, favorite locations, Paris, Norway, Iceland. Print there are 3 locations. And then this function will print the favorite locations. Def show favorite locations, print your favorite locations are plus favorite locations. Print count locations. So when we call this, favorite locations equals Paris, Norway, London, and so this will just print cal locations, and this doesn't have access to favorite locations, so this will be a name error. Yep. Looking at the error, it seems like the main issue is that favorite locations is not defined. Why would our program not be able to see our beautiful favorite locations variable? Aha, it must be a scope issue. Fix the scope of favorite locations so that both of our functions can access it. So what I would do is copy that. Cool. Returns. At this point, our functions have been using print to help us visualize the output in our interpreter. Functions can also return a value to the program so that this value can be modified or used later. We use the Python keyword return to do this. Here's an example of a program that will return a converted currency for a given location a user may want to visit in our trip planner application. So def, calculate exchange USD, US dollars, exchange rate, return US dollars times exchange rate, New Zealand exchange equals calculate exchange USD, 100 1.4, print $100 in US currency would give you plus string New Zealand exchange plus New Zealand dollars. This would output $100 in US currency would give you 140 New Zealand dollars. Saving our values returned from a function like we did with New Zealand exchange allows us to reuse the value in the form of a variable throughout the rest of the program. When there is a result from a function that is stored in a variable, it is called a returned function value. Let's try to return some data in the exercises. Working with multiple functions can be a bit overwhelming at first. Don't hesitate to use hints or even look at the solution code if you get stuck. Our travel application is getting really popular. Some of our users have posted on social media that it would be useful if our application could help them track their budget during trips. We want to help them track their starting budget and let them know how much they have left after an expense. We have provided some starting code to get started. Take a second to understand the code and then click run and take a look at the output. So current budget equals 3500.75. Def print remaining budget takes in budget. Print your remaining budget is $ plus string budget. Print remaining budget with current budget. So take a second to understand the code and click run. Take a look at the output. Your remaining budget is 3500.75. Let's create a new function called deduct expense. Deduct expense. That will take two parameters. The first parameter will be budget, and the second parameter will be expense. Our function will be taking in a budget value as well as the expense we want to subtract. We will want our function to return the budget minus the expense our travelers are incurring. So it looks like the most common expense our travelers are incurring is a t-shirt purchase. Let's create a variable called shirt expense, and for now we will give it a set value of 9. We are not accounting for currency changes at the moment. Make sure this is defined outside of the functions in your script. So shirt expense is 9. Now that we have an expense to subtract, create a new variable called new budget after shirt. And set it to be the function call of deduct expense. Pass our current budget variable as the first argument, and the shirt expense variable as the second argument. Lastly, we want our users to see the remaining budget. Call the provided print remaining budget function, passing in new budget after shirt as the only argument. So print remaining budget, new budget after shirt. Great job. This is the biggest program with functions we have built so far. Take a second to review your code and click run one last time when you're ready to move on. Multiple returns. Sometimes you may want to return more than one value from a function. We can return several values by separating them with a comma. Take a look at this example of a function that allows users in our travel application to check the upcoming week's weather starting on Monday. Weather data equals sunny, sunny, cloudy, raining, snowing. Def 3-day weather report weather. First day tomorrow, the weather will be plus weather 0. Second day, the following day, it will be plus weather 1. Third day, 2 days from now, it will be plus weather 2. Return first day, second day, third day. This function takes in a set of data in the form of a list for the upcoming week's weather. We can get our return function values by assigning them to variables when we call the function. Monday, Tuesday, Wednesday equals 3-day weather report, weather data. Print Monday, print Tuesday, print Wednesday. This will print what you see here. Let's practice using multiple returns by returning to our previous code example. Our users like the previous functionality that we added to our travel application, but recently we had an influx of users planning trips to Italy. We want to create a small function to output the top places to visit in Italy. Another member of our team already started on the implementation of this feature, but it is still missing a few key details. Take a second to review the code and click run when you are ready to move on. For now, there will be no output. So def top tourist locations Italy, first equals Rome, second Venice, third Florence. We want to be able to return the 3 most popular destinations from our function top tourist locations Italy. Add a line in the function that will return the values of first, second, third in that exact order. Return first, second, third. In order to use our 3 return values from top tourist locations Italy, we need to assign them to new variables names after we call our function. Set the return of the function to be equal to 3 new variables called most popular 1, most popular 2, and most popular 3. So use 3 print statements to output the value of the most popular places. So oops, forgot that I copied that too. Copy this. Nice. Review. Excellent work. In this lesson, you've covered a major fundamental programming concept used in the majority of all programs to organize code into reusable blocks. To recap, we explored what problems arise in our functions, what problems arise in our programs without functions, what functions are and how to write them, how whitespace plays an important role in how a program will execute our code, and more importantly, distinguish function code from non-function code, how to pass input values into our functions using parameters and arguments, the difference between built-in and user-defined functions, and some common built-in functions Python offers, how we reuse function output with the return keyword as well as multiple returns, where variables can be accessed in our programs that use functions. Let's practice putting all these concepts together. Alright, this is it. We are going to use all of our knowledge of functions to build out Trip Planner V1. First, like in our previous exercises, we want to make sure to welcome our users to the application. Create a function called Trip Planner Welcome. That takes one parameter called name. This function should use print to output a message like this. So print, just going to copy this so I don't get typos. Print name, call Trip Planner Welcome, passing your name as an argument. So next we are going to define a function called estimated time rounded. That will allow us to calculate a rounded time value based on a decimal for our user's trip. An example call for this function will look like this, with 2.5 as the argument, where 2 represents 2 represents 2 hours and 0.5 represents 30 minutes. Define the function estimated time rounded with a single parameter, estimated time. The function should do 2 things. Create a variable called rounded time. That is the result of calling the round built-in function on the parameter estimated time. Return rounded time. After the function definition, call estimated time rounded with the decimal argument and save the result to a variable called estimate. So we'll do, got a semicolon in there. With the decimal argument and save the result to a variable called estimate. Since the amount represents the time, be sure to use a positive number. What did I do? Looks like your function is not running correctly. For the value of 50.55, it does not return 51. Check your logic, so I guess this should be a 0. Next, we are going to generate messages for a user's planned trip. Create a function called destination setup. That will have 4 parameters in this exact order: origin, destination, estimated time, mode of transport. Give the parameter mode of transport a default value of car. The program will error out if we run it, since we have not defined a function body yet. Don't worry, we'll do that in the next step. Next, we are going to write 4 print statements in our function. The output of this function you call should look like this. Traveling. Honestly, I should have just I should have deleted all that. Mode of transport. And last but not least, it will take approximately each of these print statements use a different parameter from our function destination setup. Note the estimated time parameter will come in the form of an integer. Make sure to use string to convert the parameter in your print statement. So estimated time will be a string. Oops. After the function definition, call destination setup. The following arguments. Origin and destination should be string values representing the place you will travel from and to. So from the city to the woods. It's pretty weird, but I am going to the woods. Use the estimate you created earlier from estimated time. Estimate. If you will be traveling by mode other than car, be sure to overwrite the default value of mode of transportation. I will be traveling by bike. Oh, wait. Did you use print with a string? It will take approximately string estimated time plus hours. Did I put a space here? I did. Okay, what's the issue here? Okay. So, destination setup, origin, destination, estimated time, mode of transport equals car, print your trip starts off in plus origin, print and you are traveling to plus destination, print you will be traveling by, mode of transport, print it will take approximately plus string estimated time plus hours, destination setup, the city, the woods, estimate, bike. So I thought I did. What's the issue? So your trip starts off in the city and you are traveling to the woods. You will be traveling by bike. It will take approximately 3 hours. It will take approximately 3.0 hours. Oh, it wants a space at the end. Are you kidding me? That is dumb. That's not what it is. Oh, I think this is what they want. Next, we're going to write 4 print statements in our function. The output on this function call should look like this. Your trip starts off in the city, and you are traveling to the woods. You'll be traveling by bike. It will take approximately 3.0 hours. Each of these print statements use a default parameter from our function. Use a different parameter. The estimated time parameter will come in the form of an integer. It's meant to come in the form of an integer, huh? Make sure to use string to convert the parameter in your print statement. Why would it come in the form of an integer, though? Because clearly we're using rounded, so it makes sense that it comes as a double. Is that the issue? After the function definition called destination setup within the argument. So clearly it says make sure to use string to convert the parameter in your print statement. So this, what we had, is right. After the function definition called destination setup with the following arguments. Origin and destination should be string values representing the places you will travel from and to. Use the estimate you created earlier for estimated time. If you will be traveling by mode other than car, be sure to overwrite the default value of mode of transport. I did all this. What's the hint? Use plus to concatenate a string variable with another string, for example, world. Hello plus world would output that. Since we know estimated time will be a number, we'll need to use the string function to convert it to a string. Here's an example. Number equals 101. Print you are taking a plus string 101 plus course would output that. Make sure to double check your spelling, punctuation, and capitalization. If you're still having issues, use the string provided in the exercise. What do you mean use the string provided in the exercise? Like this? What? So it is the fact that estimate wasn't an integer. Well, how do you, I made estimated time 0. What? Okay, whatever. It's over now. Great job. We have successfully finished our first version of the Trip Builder application. Go ahead and try passing different values into your functions. No thanks. I'm good. Let's get out of here. Let's run. Okay. What line of code can be used to return a variable innervar from it or innervar? So, okay, focus. What line of code can be used to return a variable innervar from a function back to the piece of code that called the function? So we have this variable innervar. Oh, return innervar. What happens when you call report? Time equals 3 p.m. Sorry. What happens when you call report? Time equals 3 p.m. Mood equals good. Def report. Print the current time is plus time. Print the current mood is plus mood. Print beginning of report. Report. So what happens when you call report? One string is printed, the current time is, so 2 strings are printed, the current time is 3 p.m. and the mood is good. 2 strings are printed, the current time is, so it's gonna be the second one. How do you call update with a new value of 20? Def update, new value equals 10, old value equals new value, call update 20. Which variables can be called in the blank spot in this code? Counter equals 0, def update, new counter equals counter plus 1, return new counter. And it's asking which variables can be called in the blank spot in this code, only counter. What line of code will call force with a value of 10? So here we see force, and we need a force value to equal 10. With a value of 10 for, what line of code will call force with a value of 10 for mass and a value of 9.81 for acceleration? So force 10 and 9.81. Oh wait, sorry, I accidentally clicked that and I was scared I got it wrong. Given the following function, will produce the output, there is no greater agony than bearing an untold story inside you. Def quote x, print there is no greater agony than bearing plus x inside you. So we need to pass an untold story. How do you call a function called setup with no arguments? Right there. Nice, nice, nice. Not doing it. projects. Let's do some code challenges. Let's go. Yeah. Python code challenges, control flow. Python code challenges involving control flow. This article will help you review Python control flow and functions by providing some code challenges. Some of these challenges are difficult. Take some time to think about them before starting to code. You might not get the solution correct on your first try. Look at your output, try to find where you're going wrong, and iterate on your solution. Finally, if you get stuck, use our solution code. If you check answer twice with an incorrect solution, you should see an option to get our solution code. However, truly investigate that solution, experiment and play with the solution code until you have a good grasp of how it is working. Good luck. Function syntax. As a refresher, function syntax looks like this. Def some function, some input 1, some input 2, do something with the inputs and return output. For example, a function that returns the sum of the first and last elements of a given list might look like this. Def first plus last list, return list 0 plus list -1, and this would produce output like this. If we pass it this list, it'll do 1 plus 4, 8 plus -8, -10 plus -4. Challenges. We've included 5 challenges below. Try to answer all of them and polish up your problem solving skills and your control flow expertise. Not sum to 10. To start, let's check if the summation of two values does not equal 10. You are given two numbers stored in num1 and num2. If the sum of num1 and num2 is not equal to 10, then store true into a variable called not10. Otherwise, store false in not10. So we have num1 equals 6, num2 equals 3. Write your if statement here. If num1 plus num2 is not equal to 10, not10 equals true. Else not10 equals false. Uncomment the below lines to show the result. So print, does the sum of the numbers equal to 10 plus string not 10. So does the sum of the numbers equal to 10? So right now it's messed up. So if num1 plus num2 is not equal to 10, not 10 equals true. Else not 10 equals false. Uncomment to show the result. Print, does the sum. Wait, what is it even asking me? Hold on. Check if the summation of two values is not equal to 10. You are given two numbers stored in num1 and num2. If the sum of num1 and num2 is not equal to 10, then store true into a variable called not 10. Otherwise, store false in not 10. Does the sum of the numbers equal 10? So I guess it wants me to like change these around so that the output makes more sense, because num1 and num2 don't equal 10. So did you create an if statement to set not 10 to true if num1? What? I'm sorry, but it was already right. So what? How is this a challenge? Here's how we solve this one. If num1 plus num2 is not equal, so, oh, you know what it is? I think I've done these before. I think it saved what I already did. Let's see. Over budget. Let's say we are trying to save some money and we are watching our budget. We need to make sure that the result of our spending is less than the total amount we have allocated for each of the categories. Coding question. You are given a monthly budget and some expenses, and need to check if the sum of the expenses goes over budget. First, store the total of all expenses into a variable called total. So, and then next, okay, so first, store the total of all expenses into a variable called total. Calculate total amount. So total equals all of this. Internet bill plus rent. So store the total of all expenses into a variable called total. Next, check if the total is greater than the budget. Check if the total is greater than the budget and store the result in over budget. If total is greater than budget, over budget. equals so I'll copy this, delete it. It's not actually an if statement. It will just make over budget equal to whether that's true or false. So you were given a monthly budget and some expenses and need to check if the sum of the expenses goes over budget. First, store the total of all expenses into a variable called total. Next, check if the total is greater than the budget. If it is, store true into a variable called over budget. Otherwise, store false in over budget. Uncomment the lines below to check the results. So total 1860. Is it over budget? False, because our budget is 2000. Did you use an if statement? Wait, why do we need to use an if statement? I did it in a better way, but it's still making me do this. Just leave me alone. Large power. For the next code challenge, let's add functions to the mix. We create a function that tests whether the result of taking the power of one number to another number provides an answer that is greater than 5,000. We will use a conditional statement to return true if the result is greater than 5,000, or return false if it is not. In order to accomplish this, we will need the following steps. First, define the function to accept two input parameters called base and exponent. Second, calculate the result of base to the power of exponent. Third, use an if statement to test if the result is greater than 5,000. If it is, then return true, otherwise return false. So first we're going to create a function named large power. Takes two parameters, base and exponent. If base raised to the exponent, so if base exponent is equal to, it's greater than 5,000. It's greater than 5,000. Return true. Otherwise, return false. Uncomment these functions. Just test your large power function. True and false. Check answer. Awesome. All right. These are not really challenging for me, so it's just making me tired, honestly. Python code challenges, control flow, advanced. Oh, let's go. Difficult Python code challenges involving control flow. This article will help you review Python functions by providing some code challenges involving control flow. I get it. Function syntax as a refresher. Okay. Am I gonna rule that I didn't read these? For example, function that returns the sum of the first and last elements of a given list might look like this. Def first plus last list. Return list. Okay, I got it. So in range, let's start the advanced challenge problems by testing if a number falls within a certain range. We will accept three parameters where the first parameter is the number we are testing, the second parameter, so first param num test, second param low bound, third, ooh, what the hell? Param lower bound, third param upper bound. These are the steps required. Define the function to accept three numbers as parameters. So create a function named inRange. Num test. Oh, it's telling me what I have to make them called. That takes the style out of it. The function should return true if num is greater than or equal to lower. So if num is greater than or equal to lower, return true. To lower and less than or equal to upper. So if num is greater than or equal to lower and num is less than or equal to upper, otherwise return false. Uncomment these function calls to test your inRange function. Print should be true, so the first one we should get true false. What I do wrong? Oops. Invalid syntax. Oh yeah, this is not C++. Oh, I see. So define in range num lower upper. If num is greater than or equal to lower and num is less than or equal to upper, return true. Else return false. For some reason, when we call this print in range 10, 10, 10, we're getting back true, false for each one. So if I comment this out, we get true. Okay. And if I comment this one out and uncomment this, we get false. Oh, okay. So if I uncomment both of them, oh, bet. Here's one way to do it. So what they did was they just did if num. So pretty much the same thing that we had, well, that I had originally. I didn't think I needed the else, and I really didn't. But the fact that it was being buggy with the output had me confused. It's kind of buggy on Codecademy. I mean, it's not the end of the world, but I've noticed it a decent amount as I've been using it. So, same name. We need to write a program that checks different names and determines if they are equal. We need to accept two strings and compare them. Here are the steps. Define the function to accept two strings, your name and my name. So, create a function name, same name. Name. If our names are identical, return true, otherwise return false. Let's do it in a cool way. Uncomment these function calls to test your same name function. First one should be true, second one should be false. Awesome. Always false. There are some situations that you normally want to avoid when programming using conditional statements. One example is a contradiction. This occurs when your condition will always be false no matter what value you pass into it. Let's create an example of a function that contains a contradiction. It will contain a few steps. First, we define the function to accept a single parameter called num. So, def always false takes a num. What's it going to do? Use a combination of less than, greater than, and to create a contradiction in an if statement. If the condition is true, return true, otherwise return false. The trick here is that because we've written a contradiction, the condition should never be true, so we should expect to always return false. Using an if statement, your variable num and the operators make it so your function will always return false, no matter what number is stored in num. An if statement that is always false is called a contradiction. You'll really want to do this while programming, but it is important to realize it is possible to do this. So we'll do something like if num, so we'll do if 10 is less than num, which is greater. I don't think you can do that. We'll just do it simply. If num is less than 10 and num is greater than 20, return true. Otherwise, we're going to return false. And all of these should print false. Okay. These are actually kind of boring. I'm bored. Let's see what the advanced list challenges are like. So, every 3 numbers. Let's start our challenging problems with a function that creates a list of numbers up to 100 in increments of 3, starting from a number that is passed to the function as an input parameter. Here's what we need to do. 1. Define the function to accept one parameter for our starting number. So, def every 3 nums, takes in parameter named start. Function should return a list of every third number between start and 100 inclusive. So this is where my list skills are put to the test. So turn a list of every third number between start and 100 inclusive. There's a method to do this. What is it? Start dot count. The function should return a list of every third number between start and 100. For example, every 3 nums, 91, should return the list 91, 94, 97, 100. If start is greater than 100, the function should return an empty list. Okay. This is advanced. Okay, let me eat my words. Let me go back to where it's safe. Let me just refresh my memory with lists back in the simple ones. How do I go back? There's no escape. Just pain. Only pain. What's happening? That's what I'm talking about. Okay. Append size. For the first code challenge, we're going to calculate the length of a list and then append the value to the end of the list. Here's what we need to do. Define the function to accept one. Let's just go to this. Create a function called append size. Def append size. That's one parameter in my list. The function should append the size of my list inclusive to the end of my list. So my list dot append should append the size of my list. Append len my list. Append the size of my list inclusive to the end of my list. The function should return this new list. So for example, if my list was 2342.108, the function should return 2342.108.3 because the size of my list was originally 3. So def append my list dot append length my list. So we'll just return that. See if it works. So, oh yeah, because append doesn't create something. So what we have to do is new list equals. Oh yeah. Wait, hold on. Overcomplicating it. Cool. Append sum. Write a function named append sum. That's one parameter. List name my list. It should do this process so the function should add the last 2 elements of my list together and append the result of my list. So new num equals my list -1 plus my list. Goodness. -2 my list dot append new turn my list. So we add the last 2 elements of my list and append the result of my list. Should do this process 3 times and then return my list. So range for I in range 3. New num equals my list -1 plus my list -2. My list dot append new num. Does this 3 times and then it returns my list. So print append sum 112. See what we get. Is that correct? You got it. Write a function named large list that has 2 parameters named my list 1, my list 2. The function should return the last element of the list that contains more elements. So um, len1 equals my, so length of my list, len2 whose length of my list 2. Gotta put this 1, and then if len1 greater than len2, return the last element of the list that contains more elements. Return my list 1 -1, else return if both lists are the same size, then return the last element of my list 1. So we'll do if length 2 is greater than length 1, return my list 2 -1. Otherwise, we'll just return the last element of my list. So let's return my list 1 -1. Uncomment the line below. So print larger list 4, 10, 2, 5, -10, 2, 5, 10. They're the same, so we're printing out the last element of my list 1, which is right. Here's how they did it. So they did it kind of in a better way, but whatever. Create a list name more than n. I'll create a function name more than n. I don't know why I thought I saw a list. That has 3 parameters named my list, item, and n. Function should return true if item appears in the list more than n times. The function should return false otherwise. So if function return true if item appears in the list more than n times. If item in my list more than n times, return true. Obviously that's not right. So how would I solve this? I'd say for item in, well, I don't want to use item. So for element in my list, if element is equal to item, count plus equals 1. Let's initialize count. It's probably a way better way to do this, but this is how I'm gonna do it. So whatever. So for each element in my list, if the element is equal to item, count plus equals 1, and the function return true if item appears in the list more than n times. So return count greater than n, and the function return false otherwise. Let's see how it goes. Is this right? We did it. How'd they do it? So what they did is if my list.count item is greater than n, return true. I just forgot about count. We use the count function to count the number of items. To count the number of times items appears in my list. You could also do this manually by looping through my list and incrementing a variable every time you see item. We then compare the result to n, which is how I did it. Combine sort. So write a function named combine sort that has 2 parameters named my list 1 and my list 2. This function should combine these 2 lists into one new list and sort the result. So new list equals my list 1. I'm pretty sure you can't just add them, right? So the way you do that. I know you can't do this. I'm gonna just do it just to make sure. The phone, and then I think sort, between sort and sorted, we should return something. So new list dot sort. So I'm pretty sure sorted new list, and if we return this, but I know this won't work. Oh, see, this is why we test it, just to be sure. It did work. So you can just add lists together like that. Because if we do, oh, we can't do that, but whatever. We get the point. So you can just add lists together. Cool. What time is it? All right, that's my 2 hours. This has been fun. Getting through these. How far do I have to go? So I'm like halfway there ish. And once I have the fundamentals done, which seems like it'll take a couple more days, maybe like, I don't know, strings is a long section, dang. But that's a lot of project stuff. So I'm gonna guess like 2 more days. So it'll be by the end of this week. Then I have how much time? It'll be, so my interviews start 1, 2, like 2 weeks and some change. So by the time I'm done with this, I'll have pretty much exactly 2 weeks before the interviews start to really tackle like the more advanced stuff. But I'm feeling good. So